Alright, today you're going to be learning about the side-side-side similarity theorem and the side-angle-side similarity theorem. In the previous lesson, you should have learned about angle-angle. Okay. The side-side-side similarity theorem is if the corresponding side lengths of two triangles are proportional, then the triangles are similar. And I want you to notice that here they have triangle ABC, and that's in blue. And anytime they're comparing ABC, it is always on top. Okay, so it's consistent. And if you take a look at RST, it's always on the bottom. So you have to make sure that you're staying consistent and you're not flip-flopping back and forth. If you start with triangle ABC on top, it always has to remain on top. And if the triangle RST is always on bottom, it always has to be on bottom. So let's try our first example. It says using the side-side-side similarity theorem is either triangle DEF or triangle GHJ similar to ABC. Okay. So formulating a plan. When using the side-side-side similarity theorem, compare the shortest sides and the longest sides and then the remaining sides. Okay. So we're going to start with the shortest side. And on this one, I'm just going to compare ABC to triangle DEF. And then I'll compare ABC to GHJ. Okay, so I'm going to let ABC be blue, and then I'm going to let DEF be red. Okay, so if I look at ABC, my shortest side is 8. So I'm comparing AB, and it's 8. And I'm going to put that over the shortest side of DEF, which is 6. So DE is 6. And if I reduce those both by 2, I get 4/3 as my scale factor. Okay. Now I'm going to compare the longest sides. If I look at AB, triangle ABC, 16 is my longest side, so AC is 16. And if I look at DEF, DF, 12 is my longest side. And if I reduce those, I should get 4/3. Okay, so it's looking pretty good, but I need to make sure I compare the last sides so that way I can actually for sure say yes, they are similar. So the remaining sides, okay, so that would be BC, and it's 12. And if I look at DEF, my remaining side here is 9, and that's EF. And if I reduce those, I get 4/3. And I got 4/3 3 times, so that means that DEF is actually similar to ABC. And the way I would write that similarity statement is triangle ABC, squiggly means similar, to triangle DEF. I still have one more triangle I need to check. Okay, so that's GHJ. I'm going to go ahead and clear all these contents. Okay, so I'm going to compare the shortest side, the longest side, and the remaining sides. And I want to see if ABC is similar to GHJ. Okay, so I'm going to let the shortest sides, AB, which is 8, and I'm comparing it to my shortest side, which is GH, which is 8. And if you reduce that, you get 1. If I could look at my longest side on triangle ABC, that's 16. AC is 16. And I'm comparing that to the longest side, GJ, and it's 16, and if I reduce that, I get 1. Okay, so it's looking good so far, but I need to check the remaining side to make sure. Okay, so my remaining side is 12, which is BC, and over here my remaining side is HJ, and it's 10, and that actually reduces to 6/5. And since these are all not the same, then triangle ABC is not similar to triangle GHJ. Alright, let's move on to example 2. Example 2 states that we need to find the value of x that makes triangle ABC similar to triangle DEF. Okay, so if we're trying to find the value of x, first we need to locate where my x values are. Okay, so if we're looking at BC, we know that the corresponding side to it is EF. Okay, and you can also look at your similarity statement. You see how BC is in the second and third spot. That means it has to be similar and corresponding to E and F. Okay, so it's very important that you keep your letters in order. Okay, so we know that BC needs to go with EF, and then if we look at DEF, we have another x value here with our 8. Okay, now I don't want to put the x's in the same proportion because that would make my life difficult. So I'm going to look at AB, and I'm going to compare it to DE because that gives me a nice solid actual number that I can compare it to. Okay, and I'm going to let anything I do with ABC be red, and I'm going to let DEF be green. Okay, so first I'm going to compare AB to DE, and I'm going to set that equal to BC over EF. And that's going to allow me to find out what my x value is. Okay, so I know that AB is 4. I know that BC is x minus 1. And I'm just going to put that in parentheses because I know anything with two terms has to have parentheses. Okay, DE is 12 and EF is 18. Okay, now that I have a proportion set up, I can cross multiply. Okay, now make sure that you actually set this up into an equation. I have 12 parentheses x minus 1, and that's going to be equal to 4 times 18. Okay, and then you solve this like a normal algebra problem. Okay, I'm first going to distribute my 12 to get 12 times x, which is 12x, and then 12 times negative 1 is negative 12, equal to 4 times 18 is 72. Okay, and then I'm going to add 12 to both sides, and I get 12x is equal to 84. And then my last step, I'm going to divide by 12, and x equals 7. Now, I want to make sure that with x equaling 7, that my sides are actually proportional. So I'm going to clear all this off. Okay, and if I plug in a 7 here, 7 minus 1 is 6. And then here I get 3 times 7 plus 1, which is 8. So 3 times 8 is 24. Okay, so I'm just going to make sure that these actually end up being proportional. So if I compare 4 over 12, okay, so I did AB over DE, and I'm going to set that equal to AC, which is 8, over DF, which is 24. And if I cross multiply, 12 times 8 is 96, and also have 4 times 24, which is also 96. Okay, so we know it works for DF so far. Now I want to check and make sure that the other side is proportional as well. If I have BC, which is 6, and that's going to be compared to EF, which is 18, and that's going to be equal to, let's see, AB, which is 4, over DE, which is 12. If I cross multiply and check, I get 12 times 6, which is 72, and then 18 times 4, which is 72 as well. So they are indeed proportional. Okay, so my answer is X equals 7. Okay, so we talked about side, side, side similarity. Now we have side, angle, side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So here we need two angles that are congruent, and then we have our sides that are proportional. Okay? So let's try an example. Example 3. You are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left end using an angle measure and the lengths shown? Okay, so what we're having to do is first we need to check and see if we have our included angle the same measure. And in this case we have angle P is congruent to angle A. Sorry, that's not P, that's a F. Okay, so angle F is congruent to angle A, and they're both 53 degrees. Okay, so we do have our first angle, and then we also need to see if our sides are proportional. So FG, you can see we're going to compare to AB, okay, since they are corresponding. And then I'm going to compare 10 feet to 15 feet, because those are corresponding as well. If they reduce to the same scale factor, then these end up being similar triangles. Okay, so I'm going to compare 6 to 9, and then 10 to 15. Okay, so this is my shorter sides, and this is my longer sides. Okay, if I reduce 6 over 9, it reduces to 2/3. And if I reduce 10 over 15, it also reduces to 2/3. So these end up being the same scale factor, and they do end up being similar by the side angle side similarity theorem. So triangle A, B, C is similar to triangle F, G, H. So just to recap, you just need to make sure that you have an included angle that's the same measure, and then that you have two sides that are proportional. Okay. Alright, so just a concept summary. You have angle, angle. That means that two angles have to be congruent in order for two triangles to be similar. You have the side, side, side. That means that if all of the sides end up being proportional, then your triangles are similar. And then the last one, if you have your included angle and then the two sides with the included angle are proportional, then you have similar triangles.